Hey guys, in this video we are going to be talking about correlation and line of best fit. So we have a bunch of vocabulary words to go over first, and then we're going to talk about each of those basically. So first of all, a linear regression equation is also called the line of best fit. Now, this line is not going to go through every single point on the graph because we're dealing with scatter plots at this point. So it's not possible to have a straight line that goes through every single point. But it is the line that best represents the data that is on the graph. Okay? Now, the correlation coefficient is a number that shows you how strong that data is. So essentially, the closer the dots on the graph are to your line of best fit, the stronger that relationship between the two variables is. And we assign a number to that strength, and it is called the correlation coefficient. So underneath here, I have given you some numbers to consider when trying to decide how strong a relationship is. If your R, which is the correlation coefficient, if it's less than 0.2, there's no relationship between the two variables. If it's between 0.2 and 0.4, there's a weak relationship. Between 0.4 and 0.7 is moderate. If R is between 0.7 but less than 1, there's a strong relationship there. Now, if R is 1, one of the variables directly causes the other to occur. So basically, whatever your X variable is causes your Y to happen. The only way that works is if every single point on the graph is in a perfectly straight line, which means every single point would end up on your line of best fit. It's not very common. Now, to calculate the line of best fit and the correlation coefficient, we are going to use Desmos. So I have put all of the directions here for you in order to have a reference point when you're practicing these. So I'm not going to go over them right this second because in this packet we are going to do some practice problems. All right, so moving on to more definitions. If the data points on a graph seem to be increasing from left to right, this is called a positive correlation. So all that means is even though the dots are not in a straight line, if they seem to be increasing as you look from left to right, then that is a positive correlation. If they're going down from left to right, that is a negative correlation. Now, if you cannot tell what direction these points are going in, they're just kind of all over the place, that is what we call no correlation. And we are going to be using these words to describe graphs all the time, okay? All right, now this next page is a little activity that we are going to do in class. I'm going to skip over the activity itself and just kind of talk about the key points here. So the reason why we're going to do the activity. And that's to be able to understand the points above the line, below the line, and exactly on the line. So any of the ordered pairs that ended up above the a line are overestimates. So that's what I'm going to write here. They are above the line. Any point that ended up down here below the line are underestimates. And your perfect estimates end up on the line. And you could do this activity yourself if you would like to. Basically, all you need to do is guess how old you think each of these people are. And after you've done every single one, find this is estimated, sorry, that's your Y. Once you've done that, actually find their actual age, decide how far over or under you are, and then write the ordered pair. And then take each of these ordered pairs and plot them. And if you do it correctly, every single one that you have that is overestimated will be above the line. Anything you have that is underestimated will be below the line. And anything you got perfectly correct will be right on the line. Okay? All right, so let's practice some more. All right, so for each of these graphs, what we're going to do is we're going to determine whether or not they are a positive, negative, or no correlation, and then describe what it means for the situation we're given. So the first one shows the relationship between the height of trees and the amount of time they are watered per day. Okay, so if you look as we go from left to right on the graph, those dots are generally increasing. So that means this is a positive correlation. We cannot say in general, or we can't say that the amount of water that you give a tree causes the height to increase, because then we are saying that it is a perfectly straight line and that one of the variables, in this case the amount of water, directly causes the other to happen, which is the height of the tree. What we can say though is that I know I said in general before, but the key word there was cause in saying that water causes the height to increase. But we can say in general, most trees grow taller with more watering. However, other factors and then you have to think about what else plays a part here. In this case, when we're talking about how tall a tree grows, it's important that they get a good amount of sunlight, that the soil is healthy and helping the tree grow. So you need to list at least one here. So I'm going to say other factors such as proper sunlight, are important for growth. Okay, so unless the points that I give you are in a perfectly straight line, you cannot say that X causes Y. Now you can say in general, this is what's occurring, but then you also have to list another factor that is included in what's going on. Let's try another. This next graph shows the results of a class test measuring the number of problems missed with the number of hours that students reported studying, okay? And again, as I go from left to right, this graph seems to be decreasing, so this is a negative correlation. And once again, it is also not a causation here. Like the number of hours you study does not cause you to miss less questions, because if you look, someone who studied for 4.5 hours didn't miss any, but someone who studied more at 5 hours still missed a question, okay? But we can say that in general, studying more helps to decrease the amount of missed questions but other factors such as, and then we have to think about what else plays a fact in how many questions you miss. Obviously, what you study matters probably more strongly than anything else, but your nutrition level, how much sleep you get, those types of things, whether or not you were cramming, all of those play a factor into how many questions you miss. But I think the most important is probably what you study. So such as what you studied plays a role in how many questions you miss. Okay. All right, moving on, we are going to talk about how to use Desmos to find the line of best fit and how to calculate the correlation coefficient. Okay, so first of all, Ashley had some guests over for dinner 8 times this month and has recorded the number of guests and the total cost for each meal in the table below here, okay? So what we're gonna do first is we are gonna take the ordered pairs in this table and we're gonna plot them. Now remember, the top is always X and the bottom is always Y. And then what we're gonna do is we're gonna put this same table into Desmos using the directions that I had on that front page, and then we're gonna answer the questions at the bottom, okay? So first of all, for 2 guests, she paid $25. And again, these aren't perfect, so you're just gonna have to estimate a little bit. So 20/40, which means 30 is right in the middle. 330, slightly above the last one. 465, so here's 60, 65. 488, so they must have had a different kind of dinner for that gathering. 690 is slightly higher. That's probably not accurate. It should be in the middle there. Okay. 115. So 110, 120, 115 is in the middle. Well, that's 110 actually. It's close enough. 160. So here's 160. And we have 150. So that would be about here. And 162. So we'll say that's there. All right. Now, we could answer this first question here, positive, negative, or no correlation. As we go from left to right, those points seem to be increasing, so this is a positive correlation. For the rest of the questions, what we're going to do is we're going to take this table and we're going to put it into Desmos and let it do all the work for us. So here we go. Let me refocus for you. Okay. All right, so step number 1 is to hit the plus icon that's up here in the left corner, and then I'm going to input a table, which we've done before. All right, so the table was 2, 25, 330, 465, 488, 690, 115, 160, and then 150, and then 162. Now, you probably noticed that the points are not showing up over here. So if you remember from first semester, what I'm going to do is I'm going to hit this magnifying glass here. You see how it says zoom fit? And it will show me where the ordered pairs are, okay? All right, now the next thing you want to do is hit the plus sign again and hit expression. Now, you don't necessarily have to do that. You could just click in the next box, and what we're going to do is we're going to type in the following expression. So it's y1, and then it's a little squiggly line. So that is the button right next to the 1, but you'll have to hold the shift. So squiggly line, that means approximately mx1, and then plus b. Now, if you do it correctly, your line should look like it goes through the middle of your data, okay? The point of the line of best fit is to have it so that it has approximately the same number of points above the line as below the line. And so it's going to be pretty close. Now, one thing I want to point out here, when you're putting this expression in, do you see how it's x1 and y1? You need to make sure that in your table you also have x1 and y1, and if you don't, if you just click there, it'll let you change that little 1 down there. If they're not x1 and y1 here, the expression will not work, okay? Now, the next thing I want to point out to you is that it gives you the m and the b, so the slope and the y-intercept. So when I go to write the equation from the line of best fit, it's just going to be y equals, and then it's mx plus b. So we're going to round. That's 23.1 for my m, so it's going to be y equals 23.1x plus my b, which in this case is negative, so I'm going to say minus, and then that's going to be 24 point, and then the 9 behind the 8 bumps the 8 to a 9, so minus 24.9. So my equation ends up being y equals 23.1x minus 24.9, and I'll show you that equation here in a second. The second thing I want to point out to you is this r value right here. That is our correlation coefficient. So we want to make sure we keep all those numbers. 0.9573. Okay? All right, so let's go ahead and take a look at what I've written down, which is all the information I just talked about. Here we go. Now, the last question we need to answer is, what does the R value tell you about the correlation? So if you go back to that front page that we talked about, our correlation coefficient is 0.9573. So that falls into this bullet point right here. It is above 0.7 but less than 1. That means it's a strong relationship. So the R value tells us that this is a strong And then I'm going to go back to what I wrote here. It's positive. You should be using two words. Strong positive correlation. Okay, so you need to say one of these words. So it's either, if there's no relation, you're just going to say no relation. So it's going to be weak, moderate, or strong. And then you're going to say positive or negative. Let's try one more. Okay. The data in the table for this problem shows the amount of milk that a baby goat gets based on its weight. So we're going to follow the same steps. First, what I'm going to do is I'm going to take this table and I'm going to plot the points the best I can. So we have 5, 12. Now notice, let's see, we have 5, 10, 15. These are going up by 5s, 5, 10, 15. These are going up by 5s. So 5 pounds, 12 ounces, so 5, 10, and just a little bit above. 7, so that's a little bit here, and 16, and again, these aren't going to be perfect. 10, 20. Then we have 15, 28. 20, 32. 25, 40. 30, 48. 40, 64, and 50, 80. Now, if you notice, these points look very, very close to a straight line. And again, I'm approximating, so I could have been off, and maybe it is a straight line, but we're going to let Desmos tell us. But it does make sense that it would be in a straight line because this is probably a proportional relationship here, but we're going to take a look and find out for sure. Now, one thing that is for sure is as I go from the left to right, this is increasing, so this is going to be a positive correlation. Okay, now let's let Desmos tell us the rest. Focus. All right, so the first thing I'm going to do is hit the plus sign so I can put in a table. And my table was 5, 12, 7, 16, 10, 20, 15, 28, 20, 32, 25, 40, 30, 48, 40, 64, and 50, 80. And then once again, I'm going to hit this magnifying glass so that it rezoom fits so I can see my data. So even on Desmos, it's not perfectly in a straight line. So this is not a causation. Now I want to figure out what my expression is. So plus sign expression. So it's y1 squiggly line mx1 plus b. Okay, so there's my line of best fit, which I forgot to sketch on the last graph, so we'll have to make sure we do that here. So my m is 1.5, so that gives me y equals 1.5x, and then my b is 4.5, so plus 4.5. And my r value is 0.9984, which is very, very strong. It's almost at 1, but it's not. All right, so I'm going to go ahead and sketch my line. It looks like the one that's on the 20 is below, let's see, it goes through 40, the one on the 40. You see how this dot is red? That helps me decide. And also this point here, which is probably supposed to be 5. Okay, so I've circled those points on my graph so that we can go through and draw our line. I grab a ruler or some kind of straight edge here. Okay, so it's going to go through those 2 points and be very, very close to a straight line here. All right, and then here is the equation that I wrote, and since this is almost 1, that means it's definitely strong. So this is a strong positive correlation. And again, we should have drawn the line of best fit on the last graph, so make sure that you practice that as well. But that's it. That's how you do correlation and line of best fit.